So students, today we are going to discussing about potentiometer. Okay. So as we have studied in the theory that potentiometer is actually a device to measure or compare EMFs. So in our potentiometer we have some 10 wires. Okay, so 10 wires like this, and these are actually conductors. So here these are actually conductors. So actually these 10 wires are actually counted. The length of these 10 wires are actually counted, and these 10 wires are having some resistance of like 2.4 ohms each. The same wire that is used in meter bridge I was talking about it yesterday. So here we have a potential difference. We need to give a potential difference. So actually what happens here, we have a 10 wires, and these 10 wires, each of one has a resistance of 2.4 ohms. That is, total 10 wires will make 24 ohms resistance. So this is basically a resistance, and typically current flows through here. That means suppose if I apply a potential of 4 volts over here, so we will have a difference of 4 volts along these 2 points, potential difference of 4 volts. Now suppose we need to measure an EMF. So in that case, will the known EMF, the unknown EMF, suppose this one is the unknown cell of which I am going to measure the EMF. So we are having a unknown EMF here. I am connecting a galvanometer over here, and then we have a pointer again. Now this pointer can move from any place. So I can connect this pointer over here, over here, over here, anywhere I wish. Okay. So this is a pointer which I can connect anywhere in the place. So what happens? Suppose this cell has an EMF of 2 volts. Suppose, okay. I'm just considering that we know this potential to make you understand. So suppose this has a potential difference of potential of 2 volts. Now, if I just move the pointer and connect like here, suppose if I connect here, and then I see that there is no current flow through this galvanometer, so there will be no deflection in the galvanometer. And if it doesn't have any deflection, in that particular case I can say that the potential difference between this point and this point is equal to the potential difference of this one. As they are same, there is no current flow through this path. So in the case where we don't know this EMF, I am just considering this to be E. This is my unknown EMF, and this EMF I need to find. So we have over here 4 volts, and this 4 volts is actually dropping along this 10 wires. So each one wire has a length of 1 meter, or I can say 100 centimeter. So actually 10 wires will make then 10 meters or 1000 centimeters. So across 1000 centimeters, we will have a potential difference of 4 volts here in this case. I have applied 4 volts over here, and that is having a potential difference between this 1000 centimeters. Now suppose when I am measuring this unknown EMF, if I don't know the EMF, I have to search for this null point. Okay. Now suppose I connect this pointer to here, and I get a null point. That means the potential difference between this point and this point is equal to the EMF of this one. Why I am getting EMF? Because as there is no current flowing through this cell, there will be no potential drop for the internal resistance of the cell. So actually I will be getting EMF. So you already know this in your theory. So suppose here I get a null point, and we will have a scale over here of 1 meter as I showed in the meter bridge. So eventually I will be able to find the length of this one. Now I am just considering the length is L. So length from this end is L. That is what I am considering right now. So this is L. The total length of this wire is actually, see, here I got null point after one wire here, 2 wires, 3, 4, 5. Okay, so here actually 4 wires I have got null point. You can see this is the first wire, second wire, third wire, fourth wire, plus this L. So actually I have got a null point at 400 plus this small amount L. So this is up to here is 400 plus L. So here I have got a null point. So actually I can say if we have a potential drop of 4 volts around this 1000 centimeter, so for 1 centimeter we will have a potential drop of 4 by 1000 obviously, and for this centimeter we will have a potential drop of 4 by 1000 into this length, which is 400 plus L. Okay, I am writing this one again over here. So it is actually 4 by 1000 into 400 plus L. So this is my potential difference between this point and this point. And this difference is equal to the EMF of the cell. So if I know L, I can easily tell this is the EMF of the cell. Now see, in this case, in this practical, we can perfectly measure the EMF of the cell because there is no current flow through the cell, as I told you earlier. And as there is no current flow through the cell, there will be no potential drop inside the cell. So we will get the EMF. As we already know in the theory that suppose EMF is E and a current flows through the cell, suppose it has an internal resistance of R. So if a current I flows through the cell, due to the internal resistance R, it will have a potential drop of IR. So ultimately, we will get this potential difference if current flows through here. But in this practical, we have no current flow through this here, so this is 0. So what we will get? I will get the potential difference, and that is equal to the EMF. So this is how we measure the EMF. That is, we have a particular potential difference applied across the 10 wires. We are getting another point here. So we need to find what is the length of this wire. So if we are getting 4 volt across this 1000 centimeter, so obviously across this length we will get a potential difference of this, and this is equal to the EMF of the cell. So this is how we find the unknown EMF, and that is the use of a potentiometer. So that's it.